In this lecture, we'll see another exceptional case by applying the big M method. The exceptional case is the case of the unboundedness of the LPP is objective. Let's say the LPP is maximize Z equals to x1 minus x2 subject to the constraints minus 2x1 plus x2 is less than equal to minus 1 minus x1 minus 2x2 less than equal to minus 2. The variables are all non-negative for all I. So the first thing is to convert this into equations. But before that, what you can do is actually multiply the equation by a negative so that the right hand side of the equations becomes non-negative. So this is twice x1 minus x2 is greater than equal to 1. This is x1 plus 2x2 greater than equal to 2. Objective is max Z equals to x1 minus x2. Now how to convert? Since they are all greater than equal to, so we'll be using a surplus, an artificial in both these. So let's say the surplus is minus S1, the artificial is A1, here the surplus is minus S2, the artificial is A2, and then these equations, the inequalities become equalities. So this is equal, variables xi non-negative, both the surplus non-negative, ai is non-negative, and the objective changes. So for a maximization problem, the penalty is minus ma1 for the first artificial, minus ma2 for the second artificial, where m is positive and m is very large. So this is for all I. Now make the table. So the table becomes, variables are, I will write CB, basic variable, x1, x2, s1, a1, s2, a2, RHS and theta j. So the coefficient is 1, minus 1, 0, minus m, 0, minus m, 2, minus 1, minus 1, 1, 0, 0, 1, 1, 2, 0, 0, minus 1, 1, 2. So the basic variables are a1 and a2. a1, a2, minus m, zj minus cj. The first is minus 3m minus 1. The next is minus 2m plus m is minus m plus 1. The next is m. The next is 0. The next is m. The next is 0. Don't calculate this. Now since we are solving a maximization problem, so what variable enters? Most negative. Most negative enters. The leaving ratio comes out to be, this is half, this is 2. So this leaves, the pivot value is 2. A1 is leaving with, A1 is leaving and x1 is coming. x1, a2, x1 का coefficient is 1, x2, a2 का minus m. Pivot को 1 बनाना, divide by 2. This is minus half, half, 0, 0, half. इसके नीचे 0 बनाना है. So what you do, multiply this row by minus 1 and add it to the second row. So minus 1 into minus half, half plus 2 is 5 by 2. Half plus 0, minus half plus 0, minus 1 into 0, 0, 0, minus 1. This is 1, minus half plus 2, that is 3 by 2. So Zj minus Cj calculate करते हैं. So the first value is 0. The next is minus 5 m by 2 minus half plus 1. So this is minus 5 m by 2 plus half. The next value is minus m by 2 minus half. This value is, don't calculate this value because a1 has already left, so you can leave this. This value is m. This value is 0. Don't calculate this. Now what is most negative? Most negative is this. Okay, this entire portion. Okay. So what is the leaving variable? Leaving variable के लिए ये रेशियो नहीं लेना. इसका रेशियो आ जाएगा 3/5. So this is leaving. And where is the pivot? This is the pivot. So x1 remains, a2 leaves, and what comes? x2 comes. So x1 का coefficient is 1, x2 का -1. So pivot को 1 बनाना है, multiply throughout by 2/5. So this is 1. So this is 1/5. So this is -1/5. This is -2/5. This is 2/5. And this value is 3/5. Pivot के ऊपर यहाँ चाहिए 0. अभी दिखता है -half. So multiply this row by half and add. So ये 1, ये 0. 1/10 minus half. 1/10 minus half is, this is 5 minus 4/10 minus 2/5. So this is the value. Half into minus 1/5. So this value comes out to be 2/5. This is -1/5. -1/5 plus 0 is -1/5. This is 1/5. This is half into 3/5 is 3/10. 3/10 plus half, which is 10. 3 plus 5, 8/10. So that is 4/5. Calculate Zj minus Cj. So Zj minus Cj is, this is 0. This is 0. S1 का कितना आता है? S1 का you have -3/5. Okay. Leave this. S2 का आता है. S2 का is coming 1/5. A2 का you can leave. यहाँ पे वैल्यू निकाल सकते हैं because artificials have left. 4/5 minus 3/5 is 1/5. Now again most negative enters. And what is the leaving variable? This you don't calculate. इसका आ जाएगा value 3. So 3 leaves. Pivot is 1/5. So x1 stays, x2 is going and s1 is coming. x1 का coefficient is 1, s1 का 0. Pivot को बनाना है 1, so multiply throughout by 5. 0, 5, 1, -1, -2, 2. This is 3. Pivot के ऊपर यहाँ पे 0 चाहिए. So multiply this row by 2/5 and add. So this is 1, this is 2, this is 0, this is also 0. This is -4/5 minus 1/5 minus 5/5 is -1. ये 1. Multiply this by 2/5. 6/5 plus 4/5 is 10/5. 10/5 is 2. So calculate Zj minus Cj again. तो Zj minus Cj के लिए आएगा यहाँ पे 0. यहाँ पर आ जाएगा 2 minus of -1 is 3. इसके लिए आ जाएगा 0. A1 के लिए you can leave. S2 के लिए आएगा -1. A2 के लिए you can leave. Z का value is 2. So Z का value is 2. Now since a value is negative, ये फिर enter करेगा. But now there is a problem. The problem is this variable, this column, the entering column is having all negative values. So this ratio will not be taken. This ratio will not be taken. So now we have a case where we see optima has not reached and there is an entering variable but there is no leaving variable. So this is the condition of an unbounded objective. So we say that the LPP's objective is unbounded. ठीक है ना? So this was the question on LPP being the optima value being unbounded. How can we see this using the graphical method? See, let's say we had this problem and we solved it using graphical method. So let's make the region. So the region is, draw this. This is say x1. This is x2. What is the first constraint? For the first constraint, x1 is equal to half. So x1 is say this, half comma 0. For x2, the value is -1. So x2 का value -1 है. Let's say this is the value. What is the line? This is the line. So are we towards the origin or away? This is 0 plus 0. 0 plus 0 is less than equal to 1, which is obviously false. So the region is away from the origin. Okay. Now draw the second constraint. Let's say this is 0. So x1 is in fact 2. So x1 का value is 2. This is say 2 comma 0. इस इक्वेशन में इसको हटा देते हैं. Sorry, इसको हटा दिया. This goes. What is the value for x2? x2 is equal to 1. So x2 is equal to 1. So this is the point and this is the constraint. Now, where is the region? 0, 0. 0 minus 0 is less than equal to -2, which is obviously false again. So the region is away from the origin. So this line said, ये पहली वाली ने बोला कि इधर रहना है. And this constraint is saying idhar. So where are the arrows meeting? Common. The common portion is in fact this unbounded region. This unbounded region is the feasible region where both these arrows are meeting. Okay, because we already have to stay in the first quadrant. So below तो plot करने का कोई मतलब ही नहीं है. इसको छोड़ भी सकते हैं. But as you can see, the region of the problem is unbounded. So what we have, that the region of this problem is unbounded, but it can also happen that even after getting an unbounded region, you might end up getting a finite objective value. So for that, we have to check. So first of all, the corners are, this is a corner, this is a corner of this LPP. First corner is this, the second is this. In order to apply the fundamental theorem of linear programming, we have to ensure that the problem is a bounded region, closed and bounded region. So what you can do is, arbitrarily, you can bound this region. Let's say I draw a constraint that is this. और वो constraint क्या है? x1 being less than equal to some capital M, where M is very large. And here M is non-negative also. So now the region is bounded and now I have more corners. What are the corners? This is the corner and this is the corner. So out of these 4 corners, I will evaluate my objective. So first of all, what is this corners? इसका coordinate कितना है? So solve this. -2x1 plus x2 is equal to -1 minus x1 minus 2x2 is equal to -2. So to solve, what you can do is multiply the first equation by 2. So this would become 4, this would become 2, and this would become -2. And now add. So this goes, this is -5x1 is equal to -4. So x1 is equals to 4 by 5. So इसका coordinate x1 का कितना है? 4 by 5. And what is the coordinate for x2? Put this value of x1 in either of the constraints. So what is the value? -2 into 4 by 5 plus x2 is equal to minus 1. So what is x2? Minus 1 plus 8 by 5. So that is 3 by 5. So this point is 3 by 5. So this point is 3 by 5. What is the other point? Other corners? The other corners are, see, this corner lies at m, comma, the intersection of this constraint with this vertical line. So ये vertical line x1 equal to m है और ये वाला constraint कौन सा है? This constraint is in fact the first constraint. So in the first constraint, put x1 equals to m, x2 equals to minus 1. So x2 is equal to 2m minus 1. So the height is 2m minus 1. So this is m comma 2m minus 1. What is this coordinate? This coordinate is m comma 0. So I have 4 corners and the coordinates are, the first corner is say 4 by 5 comma 3 by 5. The next is 2 comma 0. The next is m comma 2m minus 1. The next is m comma 0. So now I evaluate my objective at these 4 corners. The objective is x1 minus x2 and I'm trying to maximize. So 4 by 5 minus 3 by 5 is 1 by 5. 2 comma 0 रखते हैं तो आंसर आएगा 2. m minus 2m minus 1 रखते हैं तो आंसर आएगा 1 minus m. So this is 1 minus m. इस पे कितना आंसर आएगा? इस पे आंसर आएगा m minus 0, that is m. Now if I want to maximize, what should be the point of optima? See, m is tending towards infinity. So this m and this point is actually the point of optima. But this m is in my hand. I could have used this vertical line and placed it somewhere there. So m का value बढ़ जाता. That means this constraint is in my hand and I can slide it on the right and make the value of m as large as possible because m is tending towards infinity. So if m is tending towards infinity and the point of optima is m comma 0 and the optima value comes out to be capital M, this implies this is tending towards infinity. This implies the objective value is unbounded. So in this problem, we had an unbounded region and we had an unbounded objective value. Because the objective value at the optima is depending upon capital M and M is tending towards infinity. Because this line is in my hands. मेरे को ये line एक जगह पे ऐसी करनी थी, लगानी थी, जहां से मेरा ये region bound हो जाता. तो मैंने वो region bound कर दिया. और ये मैंने slide करके मैंने यहाँ पे ले आया, उठा के मैं इसको दूर कर दूंगा. Okay, so I can shift this line. So the value is unbounded. और यही चीज यहाँ पे आ रही थी. Unbounded objective. Okay. Let's take up one more example. Let's say the question is to maximize z equals to 3x1 plus 2x2 plus x3. The constraints are 2x1 plus x2 plus x3 is equal to 12. The next is 3x1 plus 4x3 is equal to 11. The variable is, there's something different given in the variable this time. It says x1 belongs to R, that is, it is unrestricted in sign. This means it is unrestricted in sign. x2 and x3 are non-negative. x2 and x3 are both non-negative. So first thing is to make the replacement for x1. So what is the replacement? We assume x1 to be a difference of two non-negative variables. So x1 dash is non-negative and double dash is also non-negative. So if we do this replacement, we get maximize z equals to 3 into x1 dash minus x1 double dash plus 2x2 plus x3 the constraint becomes 2x1 dash minus 2x x1 double dash plus x2 plus x3 is equal to 12. The next is 3x1 dash minus 3x1 double dash plus 4x3 is equal to 11. The variables are now x1 dash is non-negative, x1 double dash is non-negative, x2 non-negative, x3 non-negative. So this is the replacement that you have to do. This for x1 double dash, x1 double dash. Now we see the addition of the artificial variables. See the variable x2. X2 is in a single constraint with a positive coefficient, so this can start. That means there is a need for only an artificial variable in the second constraint, a2. So that is a2 is non-negative. So we add the penalty term in terms of a negative because the problem is a maximization problem. M is positive and M is very large. So now we make the table. This is the replacement that we have done. So the table becomes, the variables are CB, basic variable, x1 dash, x1 double dash, x2, x3 and a2. This is RHS. This is theta j. The coefficients are 3, minus 3, 2, 1, minus m. The constraint coefficients are 2, minus 2, 1, 1, 0, 3, minus 3, 0, 4, 1, 12, 11. So the starting basic variables are x2 and a2. So x2 starts and a2 starts. The coefficient for x2 is 2, for a2 is minus m. This is equal to 4 minus 3 is 1. So minus 3m plus 1. The next is minus 4. So this is 3m minus 4 plus 3 minus 1. This is 0. For x3 you have minus 4m plus 1. a2 you have 0. This is left empty. Now for a maximization problem, the variable that enters is most negative. So most negative is this value. So x3 is entering. Theta j is, this is 12. This is 11 by 4, which is smaller. So this is leaving. So what variable is leaving? The pivot is 4. So x2 remains, a2 leaves, and x3 enters. x2 का coefficient is 2 and x3 का coefficient is 1. Now this is 4, इसको 1 बनाना है, so divide throughout by 4. So this becomes 3 by 4. This is minus 3 by 4. This is 0, this is 1. This is 1 by 4. This is 11 by 4. Now ये pivot है, इसके ऊपर चाहिए 0. So what is the operation? Minus times R2 plus R1. So minus 3 by 4 plus 2. So 2 minus 3 by 4. So that gives us 5 by 4. Minus into minus 3 by 4 plus minus 2. So 3 by 4 minus 2 is minus 5 by 4. This is 1. Minus 1 by 4 plus 0 is minus 1 by 4. Minus 11 by 4 plus 12. So 12 minus 1 by 4 gives you 48 minus 11 is 37 by 4. So calculate Zj minus Cj. For Zj minus Cj we have, this is 10 by 4 plus 3 by 4. 13 by 4 minus 3. So 13 by 4 minus 3, 12. So that is 1 by 4. This is minus 1 by 4. This value is 0. This is 0. And this is the artificial variable. Either you calculate or you leave. Because as it is, it will be positive. 2 into 37 is 74 by 4 plus 11 by 4. That is 85 by 4. Now still for a maximization, you have a negative Zj minus Cj. So this would enter. So what variable leaves? Now there is a problem. In the entering column, there is minus 5 by 4. There is minus 3 by 4. That means this ratio will not be taken and this ratio will not be taken. This implies the optima, since we haven't reached the optima, since optima not reached and there is a entering variable but no leaving variable. This implies unbounded objective.